In the last segment, we talked about concentration units based on the mole. The prevalent unit is molarity. We did a few problems together, and for perspective, about 16 molar is about as concentrated as it gets. Okay, so 16 molar is what I call eat your face off. If you have 16 molar acid or base, it can literally eat your face off. So numbers like this are perfectly reasonable. Okay? We're going to begin segment 9 with diluting, because from a typical laboratory standpoint, diluting is usually easier and more prevalent than anything else. How many milliliters of 12 molar HCl are required to make 350 milliliters of 3.50 molar solution? Well, again, 12 molar HCl is very concentrated, and you'd want to be very careful with that. This is concentrated, this is diluted, so you would use the dilution formula. M1V1 equals M2V2. M1 is 3.50 molar, V1 is 350 milliliters. M2 is 12.0 molar, V2 is equal to X. And then you're just going to plug in M1V1 equals M2V2, and you're going to solve. Reconcile your units just like you did with gas laws. 3.50 times 350 equals 12.0 times X. Divide through by 12.0. X equals 2.29 molar. Does this make sense? Excuse me, milliliters. 2.29 milliliters. Now, sorry. X equals 102 milliliters. So what this means is you take 102 milliliters of the 12 molar and you add water till you make a final volume of 350. We're going to do something similar to this in the lab so you can see how you would make these. If I dilute 25 milliliters of 16.0 molar sodium hydroxide, and you do so carefully, okay, 16 molar, this is a base, with 150 milliliters of water, what is the final concentration? M1, 16.0 molar, V1, 25.0 milliliters, M2 equals X, V2 is the 25 milliliters that I started with, plus the 150 gives me 175 milliliters total. Okay? Then, let's make sure we're in our screen here. Okay, then you're going to plug in 16.0, 25.0 equals X, 175 divided by 175, X equals 2.29 molar. Okay? Now, for comparison, how would you prepare 450 milliliters of 2.0 molar calcium chloride from solid? Well, we know this is going to be solid because it's ionic. Okay, so that means that you're going to need a mass. Okay, so that is your clue that you're going to need a mass. Okay, so 450 milliliters, 2.0 mole CaCl2 per liter. Remember that a liter is equal to 1,000 milliliters. That's your definition of molarity. That's your clue then that you're going to go to grams and that you need molar mass. Okay, so you're going to find the molar mass of calcium chloride. Look on your periodic table, and you will find that to be 111.0 grams CaCl2 per 1 mole. Milliliters cancel, moles cancel, grams. So we're going to push some buttons on our calculator. 450 times 2 divided by 1,000 times 111 should be 99.9 to two significant figures is 100, which we would write like that. Okay, so what that means is that you're going to weigh out 1.0 times 10 squared grams CaCl2 and add water to 450 milliliters final volume. Okay, now we should be doing one of these, something very similar in the lab, so you can see how you would make something like this. Okay, now by comparison, how would you prepare the same solution if you have a stock solution already made up? Well, we're going to go from 10 molar to 2 molar, so this is a dilution. That means you're going to use M1V1 equals M2V2. M1 is 2.0 molar, V1 is 450 milliliters. These two go together. It doesn't matter if this is M1 or M2. It doesn't matter as long as these go together. M2 is 10.0. V2 equals X. You're going to use this formula, plug in 2.0 times 450 equals X times 10. Divide through by 10.0. X equals 2 times 450 divided by 10 is 90. So what that means is we're going to have 90 to 2 digits milliliters of 10.0 molar stock and add water to a final volume of 450 milliliters. And again, we're going to make a dilution in the lab as well. The next section will talk about titration, which is solution stoichiometry.